Okay, so here our intention is to find the acceleration. Okay, when you solve, what is the acceleration? A is equal to, okay, this is 2 meter per second square. That's right. So if I call this as T1 and this as T2, the tensions along this strings, what is T1 and what is T2? Okay, 6 Newton. T2 is equal to 10 Newton. Okay. So for this one, we'll write the equation. Okay. So net force, that is, what is the net force I'm writing here? I can see two forces. One is 14 Newton going to the right and T2 going to the left is equal to mass into acceleration. Mass is 1 kg, acceleration is 2, right? So what is T2 now? This means T2 should be equal to 14 minus 2. So that should be 12, right? Right. Apply the same thing for the 4 kg mass to calculate the T1, right? So when you do so, what happens? Uh, Net force is only one force that is going to right, that is T1, is equal to mass into acceleration. So that is 4 into 2, correct? For the first one. So that means 4 into 2 is 8. So T1 should be equal to 8 Newton, right? Is verified. Okay, let's solve another question of the same type. Okay, if I call this is T1, this is T2. Question is to find the values of T1 and T2. So after solving, acceleration A is equal to how much? 74 meter per second squared. T1 equals to 52.16 Newton and the T2 comes to be 22.27 Newton. All right. Next question. Find the acceleration and tension in the string. Okay, now the situation is quite different now because we are considering vertical. Okay, so there is a force of 120 Newton. This is 4 kg. This is 2 kg. Okay, so I know that there is a tension in the string that is denoted by say T, maybe this way as well as this way, both are same. Okay, and now I have to understand that this problem is slightly different because the directions of motions are different. Now this is x, this is y. So since this is upward motion, I have to take a g value, right? Assume g is equal to 10 meter per second square. There is always a acceleration due to gravity, that is downwards. All right, fine. Now let us try to write the uh, total equation corresponding to this, right? So there is something called as the acceleration, I assume, right, which is the direction in which the body is going to move, it is upwards. So there will be the acceleration like this. But because of Earth's gravity, you have a g which is acting downwards and its value is known to us. We have assumed it as some value. So these are the things which makes this problem slightly different compared to the previous problems. Alright, let's try to write now. The equation is summation f along y-axis is equal to the mass into ay, acceleration in y direction. So this can be ay. Okay, let's look at the each and every block. There is a Fy 120 going upwards, so this is positive. What is the force that externally acts on the 4 kg body? That is downwards because of Earth's gravity. So that is minus 4g. You see, this part was not there earlier. Okay, minus 4 into the gravity. Again, minus 2 into gravity. All right, is equal to, now you write the normal equation, that is mass into the acceleration. I don't know what is acceleration, but acceleration is upwards, so it is positive. So this is 4a plus 2a, right? So substitute, this is 120 minus 4 into 10, 40, minus 2 into 10, 20, equal to 6a. So a becomes equal to, so this is 60, 60 by 6, so 10 meter per second square is the acceleration. So, right, that's a point to remember whenever we have a problem is like this. Okay, then moving ahead, I just want to find out the tension over the string, tension at this string. You can use either the 2 kg or the 4 kg, but 2 kg becomes very easy for us, right? So for 2 kg, this is part B answer. The total uh, force acting upon this 2 kg body is, it can be understood if I write the simple diagram, the free body diagram. So this is the 2 kg object, right? There is tension along this and there is a force acting upon this which is 2 times the gravity, and there is an acceleration which is moving upwards. This is what I need, right? So I know that summation Fy is equal to m into Ay only for this body. So what are the forces? There is a tension upwards, there is 2g downwards is equal to mass is equal to 2 kg into acceleration is equal to 10, right? So minus 20, 2 into g, 2 into 10, 20. Going to other side is plus 20. Already there is a 20. So tension is equal to 40 Newton, straightforward answer. Okay, right. Now, once again, the question remains same. I'll change the 8.6 kg, 12.76 kg, upward force of 1276 newtons. Find the acceleration as well as the tension in the stream. So find A and find T. Okay, when we solve, we get acceleration is equal to 40.73 meter per second square, right? 15 meter. Let's move further. The next question is like this. Now we have three different blocks. This is 225 Newton, 18 kg. This is 42.36 kg. And this is 22.15 kg. So find the tensions T1, T2 and acceleration. Alright, so acceleration is equal to minus meter per second square. Okay, T2, 62.02 meter. Alright, let's move further. Okay, next question. So the question is found the acceleration of the system and the tensions T1 and T2. Okay, now this is slightly different version. All right. Now this is 2 kg, 4 kg, 6 kg. All right. So they call this is T1, this is T2. Question is to find the T1 and the T2 for the given system. Okay. Mass is 2 kg, 4 kg, and the 6 kg. Okay. So initially, let us mark some of the points. So for the whole system, there is acceleration due to gravity which is acting downwards. Okay, that is g. And anyway, so for approximated value, you can take it as 10 meter per second square. That's the first thing. And what is the direction of acceleration? Right? Obviously, the 4 kg and 6 kg mass which is present on the right side is going to pull the whole system downwards, because the other side you have a lesser weight, right? So 2 kg, so definitely the acceleration is always this direction, downwards. So that is the A value, acceleration. So for the whole system, I know that acceleration is in the same direction. That means 2 kg is not going to have the acceleration like this. It is going to move upwards with the same acceleration, right? So that's a very important point to remember, right? The 2 kg is going to have the acceleration like this, right? Fine. This is the fundamental concept I need to remember. I need to analyze when I want to apply the concept to this problem. Fine. Now let us try to use the equation for acceleration, right? So far we were using a different approach, but for these kind of problems, we can use this equation, that is a net pulling force or force divided by mass. That's the equation, but net pulling force divided by the total mass, right? You can write this as summation of F, right, in any particular direction, Fx, Fy, whatever, okay, divided by the total mass. I'll write a capital M for this. For this problem, let's try to calculate the net pulling force, right? Since the 4 and 6 kg blocks are on one side, right, and the weight of 2 kg block is on other side, the net pulling force has to be, what is the force that is automatically getting generated by this system without any external force is, right, m into g, m into g. That's the force. Okay, so 4 will be 4 into 10 plus 6 kg will generate 6 into 10, but the 2 kg is on the other side. It tries to reduce this, so that is 2 into 10 whole divided by what is the total mass of the system, that is 4 plus 6 plus 2, right? So when you simplify this, uh, 60 40 minus 20 divided by 12. Okay, so this is 20 by 3 meter per second square. Okay, so that is the uh, acceleration of the whole system. Fine, let's move further. If I want to find the tensions along the strings, right, I have to understand that if I write the T1 over here, that's the same string which is coming on the other side. So here also it is T1, right? So that's very important point. So to find T1, it's better you solve the free body diagram corresponding to the 2 kg mass. So let us try to write the free body diagram of the 2 kg. So this is the 2 kg mass. There is a tension on one side. This is T1. There is a weight acting upon of this body that is going downwards. So I can write that is 2 into 10. So that is 20. And this body is going to move upwards with an acceleration A. Right? So solve this easily you can get. So that is upwards T1 minus 20 is equal to mass into acceleration. So 2 into 20 by 3. So T1 equal to 40 by 3 plus 20, 40 by 3, so I think 100 by 3. That's the tension. Similarly, in order to find the tension T2, we can apply the free body diagram to this. So let's write the free body diagram of that body. That is 6 kg. There is tension T2, weight 6 into 10, that is 60, acceleration like this. Okay, so the equation upwards is T2, downwards minus 60, and this is equal to 6A. T2 is equal to 6 into the acceleration, that is 20 by 3. Okay, find the value of T2. Okay, very similar question. Three point 5 kg, 6.8 kg, 4.95 kg. This is 12.36 kg. So find the tensions. So let's give the names. There is a tension T1, T2, and T3. Okay, so we get acceleration is equal to 2.53 meter per second square. Yes. Then 85.2 Newton, T2 equals to, and T3 is equal to, yes. Okay, so 62.02 meters. Is that right?